The nuclear crisis at the Fukushima plant has urged Japanese people to pay more attention to renewable energy sources. Wind and solar power are at the center of public interest. Wind power currently accounts for about 0.3% of the total power generated in Japan. Two problems standing in the way of its commercial use are noise and inefficiency. Yet the new type of wind turbine may help overcome one of these obstacles. Its power output is more than twice that of the conventional models.
This wind turbine with a peculiar shape can be found at Kyushu University's Chikushi campus. It is known as a wind lens turbine, and it can produce as much as 3 times the amount of power as conventional designs. The turbine was developed by Professor Yuji Oya at Kyushu University's Research Institute for Applied Mechanics. The mechanism of the high-powered turbine is very simple. The only thing that distinguishes it from conventional turbines is a brim, called a wind lens.
It's all set now. See? Like that. You can tell it's rotating much faster. Rotating at a much higher speed. Its power output is also increasing quickly. It might double or triple. It's already about double the power.
A wind turbine with a brim diffuser is designed to accelerate wind flow as it enters the turbine. Strong vortices create a low-pressure region that draws the wind inside. That's how the power output surges. The university team wants to build a massive wind lens power plant with an output of 500,000 kilowatts. That's equivalent to the reactor at a nuclear power plant.
There is a good chance that wind lens power generation can replace nuclear power. Our society is already experiencing developments that have urged us to shift in that direction.
Kyushu University plans to launch a field study in Hakata Bay next year. Professor Oya's colleague, Professor Yusaku Kyozuka, is studying the design of bases that can be used for sea-floating wind turbines. Sea floating is more efficient since it is windier at sea than on dry land. The problem is the formidable cost of building a sturdy base that is capable of withstanding the rough marine environment.
I believe that offshore wind lens turbines will become a reliable source of energy if safety is ensured and the cost is cut to float them stably on vast sea surfaces.
Research is underway at Kyushu University to develop a less costly base strong enough to withstand the conditions at sea. The research team has experimented with a variety of prototypes and has come up with a hexagonal base. The shape makes it easier to link together and enlarge the bases. The interior space can even be used as a fishing ground, for instance.
After all, the cost is a key factor. I came up with the hexagonal shape after pursuing a simpler, cost-competitive unit.
Research on wind lenses has already progressed to the point where power output has been boosted phenomenally. The technology is now taking further strides into the realm of commercial use.